By the end of this lesson, you should be able to transfer numbers from standard form to scientific and vice versa. I'm going to move a little bit quick, but you guys are going to pause the video in class so that you can make sure you're caught up with notes. And if you aren't and it's going too fast, just ask the sub to pause the notes for you. All right. So scientific notation, if we can remember back to when we first talked about this, it's a number written as a product. That word product is super familiar because we've talked about it a bunch of times. And product just means multiplication. The product of a factor and a power of 10. The factor must be greater than 1, but less than 10. So it's super important that when we're picking our numbers and we're looking for them, that we look and make sure that they is between 1 and 10. Now, that number and the number of times we need to move our decimal impacts our b value. If we get a number that we start with, which is called standard form, if our number is bigger than 1 to start with, we're going to get a positive b value. If our number is less than 1, I'm going to get a negative b value. And that's just going to talk about how many times I multiply by 10, moving our decimal point, and dividing by 10, because that's a negative exponent, and that's what negative exponents do. So we're going to take a look at a couple examples, and we're just going to classify these. Are they scientific notation, standard form, or are they neither? So please pause the video and double check and try to sort these as you can. So here's that sort that you should have, and be careful. For our scientific notation, we should have 3 numbers. Negative 2.5278 times 10 to the negative 4th. That is a negative number, but our number in front, that 2.5, that's between 1 and 10, and that's what we're looking for. 5.32 times 10 to the negative 2. It's got a negative exponent, so I know in standard form that that number is going to be under 1. And 6.57 times 10 to the 7th, I know that that's going to be a positive number that's bigger than 1 because my exponent on the 10 is 7 right there. And the reason we use scientific notation are things like talking about distances in outer space and lengths of microbes, and we're going to take a look at those next. But let's continue on and double check. These two were on there to see if you're paying attention. You have to be super careful when you're doing this because here's a problem and here's also the problem. Both these numbers are outside of our boundary. We need to have a number that is in between 1 and 10. And 24 is way bigger than 10. And 0.4 is smaller than 1. So it doesn't fit our pattern. So this is why these two are in neither. And then our leftovers, here's what's in standard form. 84.6, negative 0.00058314, and 12,654. So we're going to take a look at how to convert them from standard to scientific and scientific to standard. Now these are some examples that are all positive exponents on the base 10. And these are positive exponents, and we'll take a look at the example for Earth because that's the one that we're given. We have 150 million, and that's equivalent to 1.5 times 10 to the 8th. On the block day, we talked about some imaginary things in math, and one of those was a decimal point. I don't see a decimal point here, but that decimal point lies at the end of the number. And to convert from standard form to scientific, I have to take that decimal point and move it. It's been moved 1, 2, 3, 4, 5, 6, 7, that gets me 15. That's not between 1 and 10. 8. 8 number of times. That's why this number right here is positive 8. Because the decimal point was moved 8 times to get 1.5 to be a number between 1 and 10. So let's take a look at Mercury. Here's our imaginary decimal point. We've got to get to a number between 1 and 10. So that means I'm going to want the decimal point in between the 5 and the 7. After the 7, it would be 57. That's too big. Before the 5, it would be 0.57. That's too small. So 1, 2, 3, 4, 5, 6, 7. So 5.7 times 10 to the 7th. You also are going to be asked to go from scientific to standard. So I moved the decimal point to the left to get from standard to scientific. So I'm going to undo that. I'm going to move the decimal point to the right to get from scientific to standard. So we have to move it this number of times, 8 number of times. So 1, 2, 3, 4, 5, 6, 7, 8. So that's where my decimal point goes. But I don't have values here, so I have to plug in zeros. So 0, 0, 0, 0, 0, 0. So 0, 0, 0, comma, 0, 0, 0, comma, 108 million is 1.08 times 10 to the 8th. Pause the video, please, and fill in the rest of the table. Please check the rest of your answers now. Please pause the video so that the students can check their work. The other option that we have is numbers that are under 1, and that's where we get negative exponents. You can already take a look at these are a little bit different because in the exponent, that's a negative number. So instead of moving our decimal point to the left, I know it's a negative number because to go from standard to scientific, I'm going to move my decimal point to the right. So 1, 2, 3. And if I stop at 3, I only have 0.5. That doesn't work. So I have to move it one more time. So I have 5.0 or 5 times 10 to the 1, 2, 3, 4. And that's a negative 4 because I get a number that's under 1. To go from scientific to standard, I'm going to start by writing out 3.0. And if I move my decimal point to the right to go to scientific, I have to go to the left to get it in standard form. And I'm going to move it 5 times. That negative just tells me to go to the left because that's where our negative numbers are, on the left. So 1, 2, 3, 4, 5. And I've got to plug in those placeholders, those zeros. So 0.00003. That's what 3 times 10 to the negative 5th is. Pause the video and try the one for the red blood cells. Here's that answer. 0.000008. 5 zeros and then an 8. Flip it on over to the back side of your sheet, and this is what we're going to be doing next, and it's multiplying and dividing scientific notations. And this is something you might not have done before, but we're going to get started doing that. We've multiplied decimals before, we've divided decimals, and we've multiplied things with the same base already in Unit 4. So, the first thing that we're going to do is we're going to regroup. I'm going to put the like parts together. So the numbers are going to go together, and my objects with the same base. All my base 10s are also going to go together. I know how to do these because they're the same base and we're multiplying. So that means I would have 10 groups of 9 and 3 groups of 10, or excuse me, 9 groups of 10 and 3 groups of 10. So all together, I'm just going to add those up. That's going to give me 10 to the 12th power. And we have to multiply these numbers. Hey, we talked about that on the block day. Largest digit on top, next digit, and we're going to multiply. Leave that placeholder. 2 times 2, double 2 is 4, double 3 is 6, and double 4 is 8. Add them up. And then we're looking for the number of place values with decimals, so 1, 2, 3. So 1, 2, 3. 11.664. So I've got 11.664 times 10 to the 12th. But wait, that's not okay. This number's not between 1 and 10. I have to move it one place to the left. And if you can remember from the front side, that meant that it was a times 10 to the positive 1, because I moved it one place. Then if I bring down this times 10 to the 12th, I can combine these again. And that's 1.1664 times 10 to the 13th. Please don't be intimidated. Give it a try and do these. Here's the next one. It happens to be a division problem, and I'm actually going to rewrite it as 12.6 times 10 to the negative 2. We've talked about negative exponents. Not afraid of that one. And 0.3 times 10 to the negative 4. So we're going to focus on this part and this part separately. If I'm dividing and they have the same base, I took the same base and we did top exponent minus the bottom exponent. That bottom exponent is negative 4. And hey, 2 negatives in a row, they both make a positive. So that number is 10 squared. So we've got something times 10 squared. Well, we can do this division. And this was 12.6 divided by 0.3. And what we did yesterday is we moved the decimal point in the divisor. So if we move that decimal point once, we're going to move this decimal point once. And that's where our decimal point's going to go. So we've got 3 divided by, or 126 divided by 3. 3 doesn't go into 1, but 3 does go into 12 4 times. And 3 does go into 6 2 times. So we've got 42 times 10 to the second. But again, that's not quite right, because 42 is not between 1 and 10. So we're going to rewrite this in scientific notation as 4.2 times 10 to the first. I've got to bring that down, times 10 to the second, and combine these. That's 4.2 times 10 to the third. Here's your next problem. Give it a shot. Please pause the video and try this and check in with your partners. So here's that work. First, regroup them. Then we're going to have the same base, so we're going to add the exponents, and we're going to multiply those numbers together. So we've got 10 to the negative 2. We're going to multiply 3.2 times negative 5.1. And when we do that, we get negative 16.32 times 10 to the negative 2. Problem is, not scientific notation. So we've got to move that over, negative 1.632 times 10 to the first, because we moved the decimal point 1 unit. And then combine your like terms. Your homework for tonight is posted on Haiku. It's a video, or it's a worksheet that just do the work in your notebook, and you'll be set to go for Monday. Have a great weekend.